friends, we discussed about the forward bias of PN junction. After that, we are going to start our discussion about the reverse bias of PN junction. What is the reverse bias of a PN junction? Already we discussed about the definition of the forward bias. Right? Okay. Now the question is that explain the reverse bias connection of PN junction. Already we discussed about that the PN junction diode is connected in two different manner as our requirement. One is the forward bias and second is in reverse bias. Now what's happened? As we connect, the PN junction diode is in reverse bias. What is the current flowing? How much current is flowing? And what is the direction of current flowing in the circuit? Right? Therefore, the reverse bias connection of PN junction. Now the definition of the reverse bias is that when the positive terminal of the external battery is connected with negative terminal, that means the N side of the PN junction, and negative terminal of a battery connected with P side of a PN junction. Such connection is known as the reverse bias. Again, when positive terminal of a battery is connected with N side of PN junction and negative terminal of a battery connected to P side of a junction, such connection is known as the reverse bias. In forward bias, positive connected with P and negative connected with N side of a junction. While in reverse bias, positive terminal of a battery is connected with N and negative terminal is connected with P side of a PN junction. Okay. So reverse bias connection of the PN junction is shown in the figure. There is the P side, there is the N side of the junction. P is connected with negative terminal of external battery and the potential is V. And N side of the PN junction is connected with the positive terminal of an external battery. So in reverse bias connection, what's happened? Already we know that when the PN junction is formed, the electric field established or the developed in the junction is in the direction from N to P. So V0 is the potential of the electric field existing in depletion layer. Now we connect the external battery in reverse bias. Therefore, the electric field due to the external battery also in the same direction of the electric field existing in depletion layer. Thus, the potential of external battery and potential existing in depletion layer are in helping condition. That means that both are in the same direction. V0 is the potential of electric field existing in depletion layer, while V is the potential of applied external battery. So as a result, the magnitude of the electric field in PN junction is increases. So what's happened? Now what is the mechanism take place in reverse bias of PN junction? Here the electric field is more. Therefore, the diffusion of the electron from N to the P region is less, because in P side of a junction of P side of the PN junction has the negative potential or the negative ionized charge, which oppose the motion of the electron. The similar way, the ionized positive charge deposited in N region near the junction, which oppose the diffusion of the hole from P to N. From P to N. Therefore, the diffusion process is stopped. Again, what's happened? In reverse bias, the electric field due to the applied external battery and electric field existing in depletion layer are in same direction. Means the potential of applied external battery and potential existing in depletion layer are in helping condition. So as a result, the total or the resultant electric field in depletion layer is increases. Thus, the electron diffused from N region to the P region is stopped because the electron has the negative charge. When diffused from N to P, at that time the negative ionized charge deposited near the junction in P side oppose the motion of electron. The similar way, the positive ionized charge deposited near the junction in N region stop the diffusion of the hole from P to N. Right? That is shown in figure. As a result, the width of the depletion layer and width of the potential barrier increases. So more and more electrons are diffused in hole in P region from N to P, and holes are diffused in N region, and they are deposited near the junction. Therefore, the electric field is going to increase under the applied external field. Thus, the depletion layer, the height and width of the potential barrier increases. That is shown in the figure. Initially, the depletion layer having this width, that is shown by the green line. Now, in reverse bias, the width of the depletion layer is increases, shown by the yellow line. Therefore, the potential barrier is also increased than the potential barrier in no connection. Blue line shows the ideal potential barrier, while the yellow line represents the potential barrier in reverse bias. Clear this? Now, so in reverse bias, what's happened? The electron finds it more difficult to move from N to P region. Electron cannot easily move from N to P region. It is more difficult to move from P to N to P. Similarly, hole to move from P to N also find the more difficult in reverse bias. But the resultant electric field is in the direction from N to P. Is in such a direction that the minority charge carrier cross the junction and constitute the current. So here negative terminal of a battery, and what are the minority charge carrier? Electron in P region get the repulsion force. Therefore, this minority charge carrier can cross the junction. Similarly, the minority charge carrier in N region are hole. Hole is the positive charge. Due to the positive terminal applied with the N side of the PN junction, this hole experiences the repulsion force. Therefore, the hole can cross the junction. Therefore, in reverse bias, the electric current is formed due to the motion of minority charge carrier from P to N, hole electron from P to N, and hole from N to P. Thus, in reverse bias, the current is very small, only due to the minority charge carrier. Therefore, that is in order of microampere. As we increase the applied external voltage, there is no change in the electric current. Therefore, this current is known as reverse saturated current. As we increase the applied voltage, but the current in PN junction is not increases, almost remain constant, and therefore this current is known as reverse saturated current. Clear this thing? Again repeat, what is the reverse bias of PN junction? When the positive terminal of a battery is connected with N side of a junction and negative terminal of a battery connected with P side of a junction, such connection is known as the reverse bias. Right? Reverse bias connection of the PN junction is shown in the figure. P is connected with the negative terminal of a battery, N is connected with positive terminal of a battery. In reverse bias connection, the electric field due to the external battery and electric field existing in depletion layer are in same direction. Both are in the same direction. Because the electric field has the direction from positive to negative terminal, here in depletion layer the positive charge accumulated near the N region and negative charge accumulated near the P region. Therefore, the electric field existing in depletion layer is also into P side, that is the same direction of applied electric field. The meaning of this, the potential of the applied external battery and potential existing in depletion layer, both are in helping condition. Both are in helping condition. As a result, the width and height of the depletion layer increases, that is shown in figure B. Initially, the width and height of the potential layer is shown by the blue line. Now, in reverse bias, there is the increase. Width is increased, height is also increased. That is shown by the yellow line. Clear this? So that is in reverse bias. Now, in this situation, as a result, the electron finds it more difficult to move from N to P, as well as the hole also find it is more difficult to move from P to N region. But the resultant electric field is in the direction from N to P. Is in such a direction that the minority charge carrier in P is electron, while in N is hole, are attacked by the external electric field. Right? Therefore, the minority charge carrier hole in P region, the electron in P region and hole in N region can cross the junction. The resultant electric field is in such a direction that the minority charge carrier in N region hole and in P region electron can cross the junction. Thus, in reverse bias, due to the minority charge carrier, current produced. And this current is in order of microampere. Therefore, the electrons are moving from P to N, holes are moving from N to P. Therefore, the electric current flowing in the circuit in the direction in a junction N to P or outside the circuit P to N. Clear this? Now, this current remains constant with the increase in voltage. Therefore, this current is known as the reverse saturated current. In reverse bias, as we apply or increase the voltage, applied voltage, the increase in current is very less. Almost remain constant, therefore that is known as the reverse saturated current. As we increase the more current, what happens? As we increase, the more applied voltage what happens? So here, the applied voltage increases, therefore, the electric field or the applied electric field is increases in such a way that it pulls down the electron from the covalent bond. Therefore, the rapid increase takes place in the current. As the current increases, then the particular point of voltage. And this point of voltage is known as the breakdown voltage we discussed in reverse characteristic of PN junction diagram. Clear this? Okay. So there is the reverse bias of PN junction. Now, after the discussion of the reverse bias of PN junction, now what is the reverse bias characteristic of PN junction? So the question is asked like to that way, what is the static characteristic of PN junction, and explain the reverse bias characteristic. Right, again the question is, what is the static characteristic of PN junction diode, and explain reverse bias characteristic. So first, what is the static characteristic? Already we discussed in forward bias characteristic. The curve I versus V of the PN junction diode. The curve I versus V of the PN junction diode is known as static characteristic of PN junction diode. Again, the definition of the static characteristic is that the curve I versus V of PN junction diode is known as static characteristic of the PN junction diode. That means the relation between the current and voltage of PN junction diode, this relation is known as static characteristic of PN junction diode. Now listen, this reverse bias characteristic of PN junction diode also in our syllabus of practical. Right? So we had to also do the graph of the reverse bias of PN junction diode in experiment, and we had to find out also the in reverse bias what is the dynamic resistance of the given PN junction diode. So that is also helpful for our experiment, and the old question asked in practical exam, that is depends on the theory of this reverse bias and forward bias characteristic of PN junction diode. Now, the circuit for the PN junction diode for reverse bias characteristic is shown in the figure. Here the symbol of the PN junction diode. The P side of the PN junction is connected with the negative terminal of a battery, and N side of the PN junction diode is connected with the positive terminal of an external battery. To measure the voltage, here the voltmeter is required, and this voltmeter is connected parallel to the PN junction diode and also parallel to the battery. Voltmeter is always connected in parallel. Right? To measure the current, here the microammeter is used, because already we discussed in reverse bias, the current is flowing only due to the minority charge carrier, and this current is in order of microampere. Therefore, the microammeter is connected in the circuit. Current measuring meter is always connected in series. Therefore, microammeter is connected in series with PN junction diode and also the battery. Right? Therefore, the circuit for PN junction diode for reverse bias characteristic is shown in figure A. That is the circuit diagram of the PN junction diode for reverse bias characteristic. In such circuit, a battery is connected with a PN junction diode through a potentiometer or the rheostat. What is the function of the rheostat or the potentiometer circuit? To change the applied voltage in the circuit. That is the function of rheostat or the potentiometer in the circuit. Clear this? So that is the circuit diagram of PN junction diode for reverse bias characteristic. Now, if the applied voltage increases, the current remains almost constant. Why they remain constant? If the voltage is increases, because in reverse bias the electric current is formed only due to the minority charge carrier. Minority charge carrier. Therefore, this current is known as reverse saturated current. That is known as reverse saturation current. Now, in the relation between the I and V, so third quadrant represents the reverse bias. As we increase the current, so what's happened? Up to this voltage, the increase in current is very less, almost remain constant. Therefore, this current is known as reverse saturation current. reverse saturation current. There is a sudden rise in the current when the voltage is increased beyond a point. If the voltage is increased beyond this point, the rapid increase takes place in the current. What is the reason? In reverse bias, as we continuously increases the reverse bias voltage applied to the PN junction diode, what's happened? In PN junction diode, there is the P-type semiconductor and there is the N-type semiconductor. Here the majority charge carriers are hole, minority charge carriers are electron. Here the majority charge carriers are electron, minority charge carriers are hole. As we connected in reverse bias, P is connected with negative and N is connected with the positive terminal. As we increase the applied voltage, what's happened? So here the positive potential increases, here the negative potential increases. When the applied voltage is beyond a point, beyond this point, what's happened? The electric field across the PN junction is sufficiently strong to pull down the electron from the background, from the covalent bond. Here, as we apply the external electric field, so electric field increase in PN junction. This electric field is sufficiently strong to pull down the electron from the covalent bond. So as a result, large number of the covalent bonds are broken after this value of voltage. So due to the numbers of the covalent bonds broken, electron hole pairs are formed. Electron holes pair are formed. As a result, the rapid increase takes place in the current. Right? And the voltage at this point is known as the background voltage. The value of the voltage at a point is known as the background voltage. If the voltage given to the PN junction diode more than the background voltage, so this PN junction diode is permanently damaged. Permanently damaged. In reverse bias mode, the dynamic resistance of PN junction is of order of 10⁶ ohm. That means the 1 mega ohm. Because in reverse bias, the more and more the ionized positive charge deposited in N region near the junction and ionized negative charge deposited in P region near the junction. Therefore, it is difficult to diffuse the electron from N to P and hole from P to N. Therefore, the electron and hole during the diffusion suffers the more resistance. This resistance is in order of 1 mega ohm or 10⁶ ohm. Clear this? Okay. Now, what is the result? After the background voltage increases, so sudden increase in the current. So as the voltage increases more than the background voltage, so electric field in PN junction region is sufficiently strong to pull down the electron from the covalent bond. So as a result, after this voltage, the large number of the covalent bonds are broken in PN junction diode. Therefore, the large amount of the hole pair are formed. So as a result, the rapid increase takes place in reverse bias mode of a PN junction diode. Again we repeat it. What is the reverse bias characteristic of PN junction diode? First thing, what is the static characteristic? The curve I versus V of the PN junction diode is known as the static curve. Static characteristic of PN junction diode. Again, the curve I versus V of the PN junction diode is known as static characteristic of PN junction diode. The circuit for PN junction diode for reverse bias characteristic is shown in the figure. Here the positive terminal is connected with the negative terminal of a battery and inside of the PN junction is connected with the positive terminal of an external battery. To measure the voltage, voltmeter is connected parallel to the PN junction diode and external battery, while the current meter is connected in series with the PN junction diode and battery. Clear this? Okay. Now, in such circuit, a battery is connected with a PN junction diode through a potentiometer or the rheostat to change the applied voltage. If the applied voltage increases, the current remains almost constant and it is known as reverse saturated or the reverse saturation current. In reverse bias, as we increase the voltage, the increase in current is very less, almost remain constant. Therefore, that is known as the reverse saturation current. There is a sudden rise in the current when the voltage is increased beyond a point. As we further increase in the voltage beyond this point, the sudden increase, so the sudden rise takes place in the current. The value of the voltage at a point is known as the breakdown voltage. So what are the voltage? Value of the voltage. Beyond this voltage, the sudden increase in current takes place. This voltage is known as the breakdown voltage. If voltage given to the PN junction more than the breakdown voltage, may damage the PN junction diode permanently. Right? Okay. Now in reverse bias mode, the dynamic resistance RAB is in order of 10:6 ohm. Or in other words, there is the 1 mega ohm. So there is our the reverse bias characteristic. This figure is not important, only for you to understand it. Right? This figure is not required. Only these two figures, figure A, figure B. So this whole graph is known as the characteristic of PN junction diode. First quadrant represents the forward bias characteristic. Third quadrant represents the reverse bias characteristic. Here it is. Okay.